All right, these are the second part of the examples I'm going to go through, and these involve questions 12 through 14 on ClassKick. And this is involving the segment addition postulate. You should have watched the 1.3 postulates video previously to this to help you understand that. So it says here, if EG, segment EG is 59, what are segment EF and segment FG? Okay, so it says here EG is 59, so from E to G. So the biggest thing, what you need to be able to do here is figure out, if you remember, that the segment addition postulate is essentially part plus part equals the whole. Okay, so what you need to figure out when you're doing these problems is which one is the two parts and what's the whole. And as you look here, you see EG, and that tells me that that's the whole segment. So I know that the whole segment is 59. I'm going to plug that in for the whole. Okay, all I'm going to do here is use substitution. EF, from here, the E to the F, is that a part or is that a whole? Well, EG is the whole line, so 8x minus 14, that's going to be a part, so I'm going to put that in here. 8x minus 14, that's EF. And then you have from F to G. And again, that's another part, so we're going to add that 4x plus 1 to that. And now you have an equation that you're going to have to solve. Okay? So in order to solve this equation, I'm going to combine my like terms here. I've got 8x and I've got 4x, and that's a total of 12x's. And then I've got a negative 14 and a positive 1. And a negative 14 and a positive 1 becomes a negative 13. Okay? And now I've got to do the opposites. I want to get x by itself. So in order to do that, I'm going to have to move that negative 13 first. In order to move it, I have to add it, do the opposite. So I'm going to add 13 here to each side of the equal sign. So the 12x doesn't change. The 13s become 0, and 59 and 13 is 72. Okay, and now in order to get x by itself, I have to divide by 12 in order to move the number. I don't want the variable to move, so I'm going to divide each side by 12. That's going to cause these 12s to cancel out, and x is going to equal 6. Now, the question that they asked you was, what are EF and FG? So they want to know how long they are, EF and FG. In order to do that, I have to plug them back in. So I'm going to plug in EF here. On EF, I'm going to plug in, there's 8, and then instead of an x is now 6, and minus a 14. Okay, 8 times 6 is 48, and minus 14 is a 34. So EF is 34 units long. Okay, and then FG, that is 4 times 6 and then plus 1. Okay, and then 4 times 6 is 24, and if I add the 1 to that, that becomes 25. So the one way I can check my answer here is, if you remember, these two are the two parts. So 34 and 59 had better add up to equal the whole, which is 59. And if I add those two together, that checks out. Okay. All right, let's look at the second example now. It says here in the diagram, JL is 120. What are JK and KL? Again, part plus part equals whole. So in this case, JL, that is the whole from J to L. So we know we're going to equal 120. And the other two parts are JK, which is 4x plus 6, and KL, which is 7x plus 15. Same kind of concept here. Going to combine my like terms. 7 and 4x is 11x. 6 and 15 is 21. Okay, and now I'm going to subtract 21 from each side. I want to get x by itself. So 11x equals 99. And then I'm going to divide by 11. And x is going to equal 9 units. Now, so x equals 9. Okay, and again, I'm going to plug that back in to find my JK. 4 times 9 plus 6, that's 36, and 6, which is 42 units. And then KL, which is 7 times 9 plus 15, that's 63, and 15, which is 78. Now, if I add 78 and 42, it's going to give me the 120. So again, part plus part equals whole. Okay, now you can complete problems 12 through 14 on ClassKick.